All right, so in this lesson, we're going to continue on with our factoring. And now we're going to learn how to deal with polynomials when there's an actual number in the x squared. So if you do recall, the first step when we're trying to factor is always try to find a GCF, or greatest common factor, between the coefficients. Now, 4 and 20, there's a GCF, but there is no GCF between 4, 20, and 9. So what that means is that we're kind of stuck with this 4 here. So what I'm going to do here is I'm going to show you the procedure that you go through in order to factor these types of polynomials, again, with a number other than 1 in front of the x squared, or basically when you have a number in front of the x squared. All right, so rather than trying to find two numbers that multiply to the constant term plus 9, we actually want two numbers that multiply to positive 36. Now, the way that I got 36 here is that I took 4 and multiplied it with the plus 9 on the back. Right? So basically, instead of finding the two numbers that multiply to the constant term, we want two numbers that actually multiply to the 4 times 9, which is 36. Okay. That being said, we are still looking for two numbers that add to the number in front of the x. Okay? So that stayed the same. Okay, so for this question here, we want two numbers that multiply to 36, right, which is 4 times 9, and add to 20, which is again is the number from the x. All right, so as it turns out, again, the factors of 36, you can kind of go through them in your head. Once you've done this enough times, you can probably do it fairly quickly. This I could do fairly quickly. All right, so I know it's going to be 18, positive 18, positive 2. All right, so these two numbers here multiply to 36 and add to 20. All right, so now what we're going to do here is with the brackets, I'm going to place these two numbers in, so x plus 18 and x plus 2. However, we are not done. Right? So this, when we expand this out, it's not going to equal the 4x squared plus 20x plus 9, because obviously there's no 4 on the x's right now. But there's a 4 the polynomial. All right, so this is the next step, which is kind of a new step, is you actually need to divide these here by the leading coefficient. This is what this is called. The leading coefficient is number from the x squared. So I'm going to write this as over 4 over 4. So draw an arrow like this. Okay, so make sure you divide the two numbers. So as a result, we'll have fractions here, right? If you can reduce the fraction, you do. Right, so in this case, 18 over 4, I can reduce that as 9 over 2. Likewise, the 2 over 4, I can reduce as 1, 2. Okay. So once I've done that, basically in the brackets here, I don't want to write equal, so I'm just going to write arrow here. So this is x plus 9 over 2 and x plus 1 over 2. So these, again, if you can reduce the fractions, you reduce them. Now, again, this here, when I expand it out, obviously it's not going to equal the original. So the last thing we need to actually do is whenever you still have fractions here, you take that number and you're going to place it actually out in front of the x's. Right? So the denominators, you pull out in front of the x's. All right, so as a result here, this here becomes bracket. So the 2 here gets kind of pulled out in front of the x, so we have 2x, and I got plus 9. And again, I have 2x plus 1. And now we are done. Okay, so this is how, this is kind of like the process. These are necessarily aren't equal to each other, but it's just this way you get to the answer. All right. Now that being said, what I also want to do here is I want to check it. Okay, so we're going to check by expanding. I'm going to follow this out just to show you that yes, it is actually this polynomial. All right, so 2x times 2x is 4x squared. 2x times 1 is 2x. 9 times 2x is 18x. And 9 times 1 is 9. And if I collect my like terms, I got 4x squared. I can put these two together. So 2x plus 18x is 20x. And then I have the plus 9. And if I compare this with, again, this is what we started off with here, notice that it is the same polynomial. So we're done. All right, so this is the process. There's actually different ways to do this. I just think that this method that I'm showing you here is actually the most efficient and quickest one. All right, but there are other ways to actually do this, just so you know. All right, so let's try this one here. Again, look for a GCF. There is none, right? So no GCF between 3, 13, and 10. So in this case, I want two numbers that multiply to negative 30. So again, that's 3 times negative 10. Make sure you also include the sign and add to negative 13. All right, well, if two numbers multiply to a negative, one's going to be negative, one's got to be positive. All right, so you might think 10 times 3, right, because that adds to 13. However, we need a difference of 13, right, not a sum. So that being said, it's actually going to be negative 15 and positive 2. Right, so it's just, if I multiply negative 15 times 2, that's negative 30. If I add them together, negative 13. All right, so these are the two numbers I'm looking for. So inside the brackets, I'm going to write x minus 15, x plus 2. And then I need to divide by the leading coefficient, or in other words, the number in front of the x squared. So this divided by 3, this divided by 3. All right. So the first bracket here, we get x. 15 divided by 3 is 5, so x minus 5. And you'll notice that the second bracket here, the fraction you cannot reduce. So what I'm going to do now is just basically take that denominator, put up top and front. So as a result, I get 3x plus 2. All right, so this should be that polynomial factored. Right, but again, it's always a good idea to check. So I'm going to check this out by expanding it out. And we get, so x times 3x is 3x squared. 2 times x is 2x. Negative 5 times 3x is negative 15x. Negative 5 times 2 is negative 10. And if I collect my like terms, 2x minus 15x is negative 13x. It's 10. Again, I'm going to compare this with the original. You can see that it is the same. We're good. All right, guys, so that is how you factor trinomials or polynomials with the number in front of the x squared. Ciao.